With the level of electronics in modern vehicles, every technician needs a multimeter. But with so many to choose from, the question is, which one to buy? Hi, I'm Haddo. In this video, we'll cover a basic introduction to multimeters and compare some of their functions. Here I have a range of meters: an analog meter, induction amp clamps, and a variety of digital multimeters. This one is relatively cheap, whereas this one here is 25 times the price of this one. So what's the difference, and which one do I need? First of all, it's worth remembering that multimeters are also used by electricians and electronics technicians, so they often include features not relevant to automotive. I'll show you which ones you will need. Here we have an analog multimeter, which is rarely used by modern automotive technicians. They can damage sensitive electronics, plus they can be difficult to read. Next, we have the induction amp clamp. These are by far the best way to measure current over 10 amps, mainly because they are quicker and safer. They can also be used to measure voltage, resistance, and much more. They can be standalone like this one, or you can get one like this that connects to your multimeter. Finally, we have the digital multimeters. These are the most common for automotive electrical work. The operating principles and functions vary between manufacturers and models. Let's take a closer look. I'll start with the rotary dial on this meter. First, we have V for voltage. This one is the same setting for AC and DC voltage. DC volts is by far the most common measurement that most techs use. Automotive meters default to DC, which is this symbol. We don't often measure AC voltage, but if required, press the function button and you will see the AC symbol. Next is this setting. The default is ohms for measuring resistance. Press the function button for diode. Next is continuity, and next is testing of condensers, which most automotive techs rarely use. This setting, HZ, is frequency. We rarely measure frequency, but if I press this button, now I can measure duty cycle and pulse width modulation, which is a must these days. This meter has HFE, which is used to measure transistor gain. It also has UA, which is micro or millionths of an amp. Neither are used in automotive. Next, we have MA, which stands for milliamps. You might not use this function when you're first starting off, but it is very useful for diagnosing problems like straight current drain. A, or amps, represents current measurement. In automotive, we only measure DC current, though some meters, like this one, can also measure AC current. Now, let's look at the jacks. All meters have at least 2 jacks, and most have 4. The black lead always goes into the COM jack, no matter what you're measuring. On the other hand, the red lead is placed in different jacks, depending on what you're measuring. For voltage, resistance, and duty cycle measurements, the red lead goes in here. For current measurements up to around 10 amps, you need to place the red lead in here. For micro or milliamps, the lead goes here. Note, ammeters must be connected in series. Now let's have a look at some of the buttons. This meter is auto ranging. Pressing the range button will put it into manual mode. For example, on this meter, I can select millivolts or volts, or change the position of the decimal point. On resistance, I can toggle between megohms, ohms, or k-ohms. The function button is sometimes called a mode button. It allows you to toggle between options on the same dial position. For example, between DC to AC. Next is the frequency button. Rarely do you see frequency and duty cycle as a separate selection. The default is frequency, which is rarely used in automotive. So you'll need to press this button to select duty cycle. The rel button is sort of like a 0 button. We mainly use this for measuring resistance. It's common to have a little bit of resistance in older test leads, so press the rel button to zero the meter before you start. Min-max is a great function that not all multimeters have. You'll find it particularly handy if you want to do a cranking voltage test. You can see the voltage dropped to 10.9 while cranking, and the charge rate was 14.7 volts. Last but not least, we have the hold button. As you'd expect, it does just that. It holds the reading on the meter. These meters here also have several additional functions. I cover these in the video on advanced functions, so be sure to watch that one. So, which meter is best for you? Basically, it depends on the type of work you do. If you're just starting out, one like this is fine. Great to learn on and not too expensive. For more advanced work, the reality is it can be difficult to get all the features you want on the 1 meter. For example, for checking a starting system, I like to check starter current draw and battery voltage at the same time. So realistically, you will need a standalone induction amp clamp and a multimeter. In summary, for general voltage and resistance testing, any of these meters are fine. For accurate diagnosis, I want a quality meter I can rely on, which is robust, fuse protected, defaults to DC and has a good warranty. It must have all the basics plus duty cycle and a min-max function. Personally, I like a bar graph as well. After watching our Multimeter Advanced Functions video, you may want one like this with all the bells and whistles too. I'm Haddo, keep training and thanks for watching.